Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Greetings to everyone. Today, our group will present on digital transformation in ship management and fleet operations. In this presentation, we will explore how digital tools such as cloud platforms, IoT sensors, artificial intelligence, and digital twins are transforming the maritime sectors. We will examine current practices, a real work case study, and discuss both challenges and opportunities as the industry embraces shipping 4.0. Here's the roadmap for our presentation. So for the introduction, the maritime industry is now entering the era of shipping 4.0, where digitalization has become a driving force for competitiveness and sustainability. Technologies like cloud computing, IoT, artificial intelligence, and digital twins are no longer optional add-ons. They are essential tools that connect ships with shore teams, improve operational efficiency, and support for better decision making. At the same time, international regulation such as the IMO's Carbon Intensity Indicator, the Energy Efficiency Existing Ship Index, and Fuel EU initiative are pushing shipping companies to adopt digital solutions. This is not just about compliance, it is about moving from reactive management toward predictive, proactive operations that reduce costs, increase safeties, and lower emissions. In short, digital transformation has become a strategic necessity for the maritime sectors. Then we go to our literature review. We identify 5 major technologies driving digital transformation in ship management and fleet operations. First of all is cloud platform, which is act as backbone of digital collaboration. They enable seamless ship-to-shore communication, improve transparency, and support compliance monitoring. However, legacy IT system and a lack of global standards remain significant barriers to full adoption. Second one is remote monitoring and predictive maintenance, which is enabled by IoT sensors, has become a game changer. Sensors collect real-time data on engines, cargoes, and vessel condition. By applying predictive analytics, operators can detect early anomalies, reduce unplanned downtime, and transition to condition-based maintenance, extending the life of assets. The third one is artificial intelligence. It's being applied to machinery health monitoring, routing optimization, and anomaly detection. Techniques like deep reinforcement learning help vessels plan safer, more fuel-efficient routes while enhancing situational awareness and decision making. The fourth one is digital twins or virtual replicas of ship and port, allow operators to simulate scenarios, test strategies, and optimize performance. They are especially useful for training, traffic management, and energy optimization. But in interoperability between system and validation protocols remain an ongoing challenges. And then finally, on our literature review is cyber security and governance that emerge as critical pillars. As operations go digital, ships become more vulnerable to cyber attacks. The IMO has introduced guidelines requiring companies to embed cyber risk management into their safety management systems. This includes risk assessment, intrusion detection, and recovery plans. While AI-driven intrusion detection shows promise, it still faces limitations due to data availability. Together, these five technologies form the foundation of digital transformation in the maritime industry, each one essential but each with its own set of challenges.
Hi, I'm Isma. Let us continue with the presentation. To see how digital transformation is applied in practice, we review the case of Anglo-Eastern, one of the largest ship management companies in the world. Since 2022, Anglo-Eastern has partnered with Wärtsilä to implement the Fleet Optimization Solution (FOS) across more than 500 vessels. This platform integrates voyage planning, performance monitoring, and compliance management into one system. The results have been significant. In 2023 alone, Anglo-Eastern reported savings of over 2,300 metric tons of fuel, which translates directly into lower costs and reduced emissions. This not only supports operational efficiency but also helps the company comply with IMO regulations, particularly the carbon intensity indicator and the energy efficiency existing ship index. To ensure consistency and security, Anglo-Eastern also established a fleet performance center where data from all ships is monitored in real time. This central hub allows for better governance, faster response to performance issues, and safer fleet-wide operations. The Anglo-Eastern case shows that digital transformation is not just theoretical, it is delivering measurable operational, financial, and environmental benefits right now. From our analysis of digital transformation between 2021 and 2025, several key insights emerged. First, cloud platforms have become the backbone of integration, enabling data sharing across ships, ports, and shore office. They provide the infrastructure that makes digital collaboration possible. Second, Internet of Things devices act as the critical data source. Sensors installed on vessels continuously collect information on machinery performance, cargo condition, and voyage progress. Without IoT, the digital ecosystem would have no raw data to work with. Third, artificial intelligence and digital twins form the decision-making core. Artificial intelligence analyzes vast amounts of data to support routing optimization, predictive maintenance, and real-time decision-making. Meanwhile, digital twins simulate different operational scenarios, providing valuable foresight for planning and safety. Another important insight is the role of predictive maintenance. Identifying early signs of equipment failure enhance reliability, reduce downtime, and lowers cost. We also found that AI-based routing improves fuel efficiency and reduce emissions, aligning operation with stricter environmental regulations. Finally, automation has eased the burden of compliance reporting. Instead of manually compiling records, automated digital systems ensure regulatory readiness with far less administrative effort. Together, these insights show that digital transformation is not only improving operational efficiency but also strengthening safety, compliance, and sustainability across the maritime industry. Looking ahead to 2025 to 2030, we see four possible scenarios for how digital transformation in ship management and fleet operations could unfold. Scenario A is compliance-centric digitalization. Here, companies adopt only the minimal digital tools needed to meet regulations. The benefit is easier audit and reduced paperwork, but the downside is missed opportunities for optimization and competitiveness. Scenario B is optimization first fleet. In this case, operators actively use predictive maintenance, AI routing, and digital twins to maximize efficiency. The benefit include 5 to 15% reduction in fuel use and CO2 emission, as well as extended equipment life. The risks, however, depend on data quality and whether crews are disciplined enough to apply the tools effectively. Scenario C is platform consolidation. This part envision unified platform that merge voyage, machinery, and compliance data into one system. The advantage is faster decision making and greater transparency, but there are risks of vendor lock-in and interoperability challenges if standards are not applied. Scenario D is assisted autonomy and resilience. Here, technologies like AI-powered collision avoidance and digital twins for port traffic management are introduced. The benefits are safer navigation and more efficient port operations. The risks, however, include the need for extensive testing, as well as stronger cybersecurity safeguards to protect increasingly autonomous systems. These scenarios show that the future could evolve in different ways, depending on how far the industry is willing to go beyond compliance and how effectively it can overcome barriers like cost, skill, and governance.
There are significant challenges that need to be addressed, while the benefits of digital transformation are evident. One major challenge is the high upfront cost associated with advanced systems such as IoT networks, AI analytics, and digital twins. These technologies require substantial investment, which can be a barrier for many operators, especially small. Another challenge is resistance to change. Many crew members are familiar with traditional way of working, and without adequate training or incentive, the adoption of new system may be low. Connectivity also remain uneven, especially when vessels are at sea or in remote ports. Real-time monitoring and predictive tools may not function effectively without reliable communication. Interoperability poses another challenges. There is a risk of vendor lock-in, which can restrict flexibility and increase long-term costs with numerous vendors and platforms available. Finally, cybersecurity risks are on the rise as ships become more connected. A cyber attack on navigation or performance system could have serious consequences for operations and safety. Companies can implement a phased investment strategy that begins with modular high-impact solutions, such as IoT tracking and predictive maintenance, to address these challenges. Additionally, providing training and change management program along with incentive can help teams adopt digital tools effectively. For connectivity, a hybrid model that utilizes satellite offshore, 5G nearshore, and Wi-Fi in ports will ensure more reliable coverage. Operators should embrace open standards and interoperable platform to prevent vendor lock-in. Finally, cybersecurity must be integrated into daily operations, supported by regular audits, encryption, and robust access control. Although there are challenges, implementing practical mitigation strategy can render digital transformation feasible and enduring. In summary, digital transformation is altering ship management and fleet operation throughout the maritime sector. Technologies like cloud computing, IoT, artificial intelligence, and digital twins are served as the fundamental drivers behind what is referred to as shipping 4.0. Our analysis highlights predictive maintenance as a key aspect. It enhances reliability, minimizes downtime, and reduces costs, while aiding compliance with more stringent IMO regulation. The case study of Anglo-Eastern demonstrates that effective implementation of digital tools can yield tangible outcomes, such as fuel saving, regulatory preparedness, and environmental advantages. Based on our analysis, we recommend an optimization first approach. This approach involves meeting basic compliance and implementing predictive maintenance and AI-driven routing to enhance efficiency and sustainability. Additionally, the company should automate compliance reporting to reduce administration burden and minimize the risk of human error. Another essential suggestion is to integrate cybersecurity into the safety management system, aligning with IMO 2025 guidelines. This strategy guarantees that as vessels become increasingly digital, they also maintain resilience against cyber threats. Operators should also get ready for platform integration by adopting universally accepted standards. This will promote interoperability, prevent dependency on specific vendors, and facilitate seamless collaboration among various systems. Performance must be monitored with specific KPIs, including reduction in fuel usage and CO2 emission, and increase in system reliability and the effectiveness of cyber governance. In summary, embracing digital transformation is no longer a choice. It is essential for achieving smarter, safer, and more sustainable fleet operations. We have a question from the audience. The question is, what is your opinion about the topic you choose? Thank you for the question. In my view, embracing digital transformation is essential, but it needs to be done thoughtfully. The advantages are evident: enhanced efficiency, reduced costs, and more intelligent operations. However, there are potential disadvantages, significant initial expenses, resistance from the team, and cybersecurity vulnerability. To me, resilience is key. The company should adopt a gradual strategy, beginning with IoT and predictive maintenance before expanding further. If executed with care, digital transformation can enhance current processes and equip the shipping industry for the future, whether that involves platform integration, autonomous ship, or new regulatory requirements.
Thank you for the question. So my answer is focused on the strategic perspective into the sustainability and competitiveness. So, in my opinion, digital transformation represents a long-term competitive advantage for shipping companies. The industry is under pressure to reduce emission and improve sustainability, and technologies like AI routing and digital twins are essential for meeting these goals. By reducing fuel consumption and cutting CO2 emissions, companies not only save money but also build trust with customers and regulators. I believe those who invest in digital tools today will lead the industry in future, because they will be able to operate more sustainably and respond more effectively to global trade demands.
That concludes our presentation. Through our discussion, we have demonstrated that digital transformation is not just about adopting new technology. It is about reshaping how the maritime industry operates. Tools such as cloud computing, the Internet of Things, artificial intelligence, and digital twins are already enabling safer, smarter, and more efficient fleet operations. Moreover, digitalization supports the industry in meeting stricter regulatory requirements, reducing costs, and moving toward greater sustainability. Digital transformation is more than just compliance. It is the foundation for smarter, safer, and more sustainable shipping. On behalf of my group, thank you very much for your attention. Thank you.